Hey guys, my name is Ryan, and so in this video's purpose is only for support and sharing only, and um, this will cover a little bit about week three, the topic of full adder. In our class SIT 111 Computer Systems, um, uh, one of one of the things that we covered in week three was full adder, and our lecturer Shalani, um, she didn't finish explaining everything about the full adder, so she said that she'll leave it for next week. So, um, yeah, so in this video, I'll explain everything about the full adder, and because since some of you have been asking me to explain, so um, I'm just going to do that in a video so that you guys can watch it later on when you need. So So this is how I understand the full adder. Again, you can if you have any questions, you can ask Shalani next week. But this is how I understood it, and I did this as a practice task by myself, and so I finished the practice task, and I'm explaining it to you in this video so that you can understand it too. So let's get started. This is the full adder. So um, you've already, hopefully you've already done the half adder. So this is the full adder, and this is the table for it. So the table obviously has the input A, B, the carry input, which we can now assume it's a C, the sum, and the carry. So anyway, so if I've already filled out um, all the numbers. So I'll skip because I, I won't have to explain you how to calculate the sum, how to calculate the carry. So I'll just skip to the um, to this part. So hopefully you know how to calculate the sum and the carry already. So yes, so I'll skip to this Boolean expression. So how to convert from the table to the Boolean expression and how to simplify it. And after that, I'll explain how to put it on a how to actually design um, the chips, and after that, I'll explain how to implement the full adder on the HDL. Yeah. Okay. So now that we've got our table, let's convert it to the Boolean expression. So firstly, we'll convert carry first. Yeah. So carry. So obviously, to convert it to a Boolean expression, all we have to look out for is the ones. So now in carry, we've got four ones, yeah? So right here, I'm just going to highlight that. Yeah, okay. So for carry, we've got four ones over here. So the first one is this line. So that should be not A, yeah, not A, B, and C. So not A and B and C, or, so this is A, yep. Sorry. So this is A, not B, that's because it's 0, so not B, and C, yep. Or, next line, this is A because it's 1, B, yep, and because it's 0, so that's a not C. Or, this other line, A, B, C, because none of it is 0. So, simple. Um, okay, so now that you've got your carry, let's look at your sum. Okay, well, I'll explain here how to simplify it later, but let's just work out one by one. So the sum. Now in sum, there's also four ones. So this is one, another one, another one. So there's also four, yeah? So the first one, that's not B, yeah? As you can see, 0, 0, so not A, not B, and C. So, yep, there you go. Or not A, B, and C. Yeah. Okay, next one. This one is A, and then not B and C. So 2 zeros, so not B and C. Next one. Obviously that's A, B, C because there's no zeros in there. See? Okay. So now that you've got your sum over here and you've got your carry here, now let's work out how to simplify, because to convert this into a, like, to design all the chips and, you have to convert it so that it's not really messy and it's much easier to see. And to put it on the HDL, to run it on the HDL, you'll need to convert. To simplify first, to this part. So I'll explain you how to simplify it. So so this part here, let's look at this part. Okay, so we'll take out C because, C is the same. So we'll take out C, and which leaves us not A and B plus A and not B, yeah? So, I mean, you've already know how to do this because we've covered this in week 3, so I won't have to explain a lot about how to do this. So just look at the ones that are similar and just pull out and then leave the rest inside. Okay, so now let's look at this part. Again, so we've got A and B similar. We'll take that out. So this is A, B. So the ones that are left inside would be not C or C. So not C or C. Yeah. Okay, so next part. So now that you've got this line here, we can look at this part. Not A and B plus A and not B. Those can be converted to A, X, or B. Yeah. It's kind of like a rule, but you just have to memorize it. And I won't explain a lot about it. I'll just go through it pretty quickly. Okay. So not C or C. These, I mean, this part right here can be converted to 1, yeah? So 1, basically, you won't have to write it down. So 1 will be, you can leave that out. So the answer for carry would be C, A, X, or B plus AB, yeah? Okay, now for sum. Basically, it works the same way. To simplify, we just have to look at the ones that are similar and take it out. So in this part right here, the ones that are similar would be A. So, sorry, not A. So we take out not A, and the ones that are left inside would be not B and C, or B and not C. Yeah, and this part here, we can also say we can take A out. So A would be here, and the ones that are left inside would be not B and C plus B and C. Yeah. Okay, now we can move on. So this stays the same. Not A stays the same, and then this part here, as I've mentioned above, can be converted to B, X, or C. And this part here, since I mean, you've already know that since if this part here can be converted to B, X, or C, then this is basically the opposite of that. So we can say B, X, or C, and we can have a bar at the top that says it's not. So in a spoken language, we can say B, X, nor C. So it should be like if I type it out, it should be this. It should be X nor C. So sorry. So yeah, sorry. Sorry, my computer keeps on capitalizing that. So anyway, B, X nor C, but we can, of course, we can erase the N, the not. We can erase the not and put it on top. So that should be a bar at the top right there. So hopefully you understand what I'm trying to tell you. So after that, after we got this part right here, we can convert it, because as you can see, um, the ones that are similar, so this whole thing right here can actually convert it to A XOR B XOR C. See? Uh, why is because look, if we copy this part here, yeah, and we can paste it like that. Okay, so let's assume that this part over here, let's assume that as Y, yeah? And let's assume this part here, sorry, as Y. Do you get what I'm saying? So, um, this, basically this part right here, let's assume that as Y, and this part right here, let's assume that as Y also, but you know, with a bar at the top, so it's not Y. So not A, Y plus not plus A and not Y, yeah? So if you look at this line right here, what can you see out of it? Basically, the answer for this, you can convert this into A X or Y. See? So you just have to point out the similarities and yeah, and just apply the rules. So this part here can actually convert it to A X or Y. Yeah. So this is, I'm just you know, explaining this to you so that you understand what I'm trying to do here. So if we assume these part as Y, then that means our answer would be A X or, so A X or, and our Y would be this. See? So yeah, pretty easy. So I'm just kind of trying to break it down to you so that you understand better. So anyway, so this is our answer right here. And so for some, because uh, for this rule right here, the general rule is that you can actually switch it around or change it around, yeah? So instead of AX or B X or C, you can put that to C X or A X or B. You can switch it around, like it's kind of like a rule, general rule. So when you have this, you can switch it around. And the reason why I switched it around is because I'll tell you later because of this. So make sure that you have it the same as your carry so that when you draw it, you won't have to, you know, use a lot of, let's say, XOR gates and, you know, so it won't get complicated. That's what I'm trying to say. So if you have this equation right here and you compare that to this equation right here, then it won't match. I mean, it when it won't match, then when you draw it, it'll get more complicated. So that's why I'm trying to switch it around so that this part here matches with here. See? Okay. So this is the answer that we get from this table. So this is the Boolean expression for carry. This is the Boolean expression for sum. Now once we've got the Boolean expression, we can draw it. And this is how I drew it. So I use this website, Logic LY, to draw it. And basically we can just, you know, drag and drop all the gates. And yeah, it took me a while to actually draw it correctly. So let me explain this to you, comparing to the Boolean expression. So so this is our carry, yeah. This is our carry. Let's start with carry first. So here's our inputs, yeah. So A, B, and our carry input, which we can assume that's a C for now. So A, B, and C, and this is our sum, and this is our carry output here, right here. I hope you can see it. It's pretty small, but so the way I'm going to explain this to you is I'm going to explain it to you backwards. So let's start with carry, yeah? So this is the carry, the light bulb right here, carry output. So basically the carry output has Let me just explain to you. Okay, so look, this is an OR gate, right? An OR gate basically is right here. As you can see, it's um, this plus right here. So that's an OR, yeah? That's an OR gate. And the OR gate leads back to AB. So the way I'm explaining to you is backwards, just to make it easier for you to understand. Because when you draw it, you'll have to do it the other way around. But when I'm explaining this to you, I'll do it. I'll explain it to you backwards. So this is an OR gate, and it leads to the AND gate, which connects from A to B. Yeah. So this is AND right here, AB. Yeah. So AB, the input will be will go into AND. Both of them will go into the AND gate before going into the OR gate. So the output of the AND gate will go into the OR gate. Yeah. And the other input of the OR gate comes from C and A XOR B. Yeah. So it comes from the C. So this is the AND gate between C right here, C. So C comes here. If you can see my cursor, you'll understand. So C goes into this AND gate, and the other input comes from A XOR B. So this is the XOR gate, yeah? And the XOR gate consists of A and B. So A and B comes into this XOR gate and then goes into the AND gate with the C, and then goes into the OR gate and then goes to the carry output. So yeah, hopefully you understand. I mean, it's a bit complicated, but if you understand, that's great. So that's a carry, and this is the sum. The sum is so I'll explain it to you. So this is the sum. First, so this is XOR, right? The XOR gate, which we have right here. If you can see my cursor right here, XOR gate. So the XOR gate consists of C, the input of C. So this is the input of C right here. So consists of C and the A XOR B. So this is the A XOR B, the gate, because it gets, as you can see, the input is A and B. It goes inside the XOR gate right here. So the equation is right here, A XOR B, and then when the output, it goes into another XOR gate, which you can see in the equation right here. So this is another XOR gate, and also include the C input, which also goes in, and then that's the output, which is the sum. So yeah, I mean that's hopefully you can understand. That would be great. So yeah, this is the design, basically the drawing with all the gates and stuff, from the Boolean expression. So from the Boolean expression, we can draw the gates. And from the Boolean expression, we can also do one more thing, which is implementing in the HDL. So let's do that now. Okay, so I won't explain much about the HDL because you've already know how to do that and how to actually put it in the software, like the Nanto Tetris. So I'm just going to explain you how to actually write the code. So basically there are two parts, um, like two main parts. So this is to calculate the sum, and this is to calculate the carry. Now I put these in these slash because just to explain you so that you won't be confused. So this is calculating the sum. So it's basically the same thing, because in the sum, as you can see the equation. Sorry, where is it? Okay, sorry. Okay, as you can see the equation right here, down below, right here. Sum, first you have to combine A and B by using the XOR gate. So we'll have to write XOR right here. So the input is obviously A, right here. The first input is A. So A equals A, and the second input, B, equals B. And then the output, you can just name it anything you like, but for me, I'm naming it A, X, or B. Simple. Now, once we've got this part right here, now let's combine it with C. So we need another XOR gate, as you can see right here. So let's do that. We'll write XOR, that's the gate, and then the input, the first input, we'll use the output from this one. Yeah, so A equals A XOR B. So the output from the first gate, we'll put it in A, and then B is obviously this one, so C. So B equals C. And the output is sum, because, you know, that's basically what we want. So the output is sum. And there you go, that's the first one. Now the second one, we have to calculate carry, which is over here, the top here, another equation. Yep. Okay, so this expression, carry equals, we can convert that. So first we'll have to figure out A and B, right? So A and B is obviously, we need an AND gate. So AND, A equals A, B equals B. It's pretty simple. And the out is, you can name it whatever you want, but I name it A and B. So there you go. And then, so once we figured out this part, this we have to figure out A. So AX or B, we've already had it in here, right? We've already had that at the top right here. Here, this equation, or this, you know, right here, this part right here. So this is, we have already had this at the top, and that is why I was telling you to switch this around earlier, so that when you get to this step, you can use the same thing to apply to it. So so let's look at this part. Okay, so C and A, X, or B. So let's have an AND gate here, yeah, and the input is C, right? So first is C, yeah, and then A equals C, okay? So B equals A, X, or B, yeah? So because the second input is A, X, or B. So A, X, or B, we can put that in. And how do I get this? It's from the top right here. We've already calculated it. A, X, or B, yeah? So, yeah, A equals C, B equals A, X, or B. Now, the output, I just named it C and A, X, or B, like that. So it won't get confusing. And then now that we've got this part calculated, then all we have to do is just combine it with A and B. So this is a plus sign, so that means it stands for an OR. So let's have an OR gate here. Yeah, the input is obviously this one, the output of our previous previous part. So let's put that there. So A equals C and A XOR B, and the B equals A and B, which we also have from the previous part at the top here. See? I hope you can see my cursor. So yeah, so B equals A and B, which is we have right here. And then the output is obviously what we want, so that's the carry, because, you know, these two part right here with the OR gate, the plus with the OR gate, so OR with AB, we have carry. So the output is carry. And there you go. That's how you put that in the HDL. And then how do you run it? We can open, sorry. So first we'll open terminal. And we'll open the hardware simulator. Hardware. Okay, so now that we've got that open, we can upload the chip in there. So I'm just going to close this because we've already done that. So input the chip. So the full adder right here. Let's load the chip. Okay. Now let's load the script to test it. Okay. So let's test the script, see if I'm correct. Okay. And then let's run it. Okay, cool. It says here, comparison ended successfully. So that means my script right here, the one that I showed you. Sorry, not my script, my code. Sorry, my code right here. It's correct. Yeah. So yeah. So that's how you implement the full adder in HDL in Hardware Simulator. So yeah. Hope. I mean, I say again. This is you can implement the full adder in many other ways, like using the half adder, using many other. There are different ways to actually implement it in the hardware simulator, and different ways to actually write the code. But this is how I wrote it, and this is how I understood it. But hopefully next week, Shalani, she'll explain more, and hopefully she'll show us like any other way that is, other way how to um, write like a different code, or maybe an easier way or a shorter way, because this is pretty long, as you can see. um, yeah, hopefully you can learn a lot from this video, and um, this is just for basically this is just um, the way I understood it. So um, if you have already understood the full adder and you've already wrote the code your way, or you've done it like any other way, using another method or something, that's great. Um, if you haven't, I hope this video can help you understand better, because it took me a while. Actually, it took me like for 2 hours just to do all this, because I did this as a practice task in week 3, and yeah, it took me 2 hours just to convert that from the boolean, from the table to the boolean expression, and to drawing this on the website, and to writing this code here, and implementing it on the hardware simulator. So it took me about 2 hours. So it's a bit time consuming, but I'm glad that I get to actually work it out myself before um, our lecturer explained it next week. So I'm glad that I you know I actually understood it by myself. So yeah, then I'll see you next week then. Thank you.